All right, so I'm going to hit go live, and then we'll just take a second here, and right at 12:30 we'll get going.
Did you want me to be sharing my screen right now?
No, you're fine. Well, I can, just do the introductions with both of your faces, and then, we'll go from there. So we are at 12:30 according to my clock here. So I'm going to just say hello, everybody, and thank you for joining us live for day 4 of Wisconsin Salt Awareness Week. My name is Allison Madison. I'm the Sustainability and Development Coordinator at Wisconsin Saltwise, which is a coalition of organizations across the state of Wisconsin that are working to reduce salt pollution in lakes, streams, and drinking water. We do that by providing training resources to winter maintenance professionals and a variety of resources for municipalities, private contractors. And one thing that we've been working on this last year is trying to increase educational resources, both for environmental education as well as K-12 teachers. So I'm really excited today to have Lexi Passante from UW-Milwaukee and Kevin Anderson from Wisconsin DPI on to share a couple different lessons that are available for K-12 teachers to teach about salt pollution in their classroom. So without further ado, I will pass it over to Lexi, who will speak first. Then Kevin will go, and if you guys have questions, please type them into the chat and we'll take those at the end.
All right. Can everybody see my screen okay? Yep, okay, cool.
Looks good.
All right, my name is Lexi Passante. I am a graduate research assistant at the School of Freshwater Sciences, and today's main topic is let's teach about salt. And my topic for this presentation is more specifically on salty sediments, what bacteria have to say about pollution. So back in fall of 2021, we had the opportunity to apply for a SIGLR outreach grant. SIGLR is the Cooperative Institute for Great Lakes Research. And more specifically, we applied for their ECO program, which is a really cool program where it stands for engagement, career training, and outreach and communications. And so when we wrote the grant, we proposed 2 outreach objectives. The first one being the collaboration with Wisconsin Saltwise, an Economowoc high school teacher, and then a Waukesha County person, creating this thing called the data nugget, and we'll get into that in a little bit. Then the second part then was working with the UW-Milwaukee's documentary film department and creating this docu-series that would increase awareness of chloride impact on our environment and document the rationale, progress, and impact of my research. But for today's presentation, we're just going to be mainly focusing in on objective 1. So before we jump into objective 1 on data nuggets, I kind of just wanted to give a brief overview of my research for those that are not familiar with it at all. Basically, we're trying to look at a different way to assess chloride impaired areas, so freshwater streams and rivers in particular, by using a biological indicator instead of taking a chloride or a conductivity reading, because the way that I see it is we can take a chloride or conductivity reading and it provides us a snapshot in time of how that ecosystem looks, but we have to remember that each freshwater system is unique and interacts in its own way. So by using a bacterial indicator, this could tell us a lot more maybe about the ecosystem health and water quality instead. And so what we started to do was we took sediment samples instead of water samples. And this is because the sediment bacterial community is going to be more stationary. It's not going to be transient like our water columns are in our streams and rivers. So that was the main point of why we decided on sediment. So we wanted to propose using halophiles as these biological indicators. For those of you who are not familiar with halophiles, these guys live in very extreme conditions, like our oceans, for example, so that high salinity. The Great Salt Lake in Utah, pictured on the right side of the screen here. And so you can just imagine it's all these very salty environments. Our study sites that we sampled sediment from are scattered within the Milwaukee River Basin. And for those that are not familiar with the Milwaukee River Basin, it's about an 883 square mile drainage area that goes directly into Lake Michigan. And what's alarming is we have found a true halophilic bacterial family across all of our study sites in the Milwaukee River Basin. And so it's no longer a question of are these guys in those environments in our freshwater systems, but they're most likely these permanent members of the bacterial community. And it's because maybe they're primed because we've been salting our roads for decades and decades. And of course, chloride pollution comes in a lot of other forms that we've been hearing about this week, like water softeners and fertilizers and things like that. So jumping into the data nuggets component. The data nuggets is a lesson plan library for educators that are looking for activities to incorporate in their classroom. So here's a screenshot of what that looks like on the right hand of the screen. And the teacher can just search different keywords depending on what they're looking for to incorporate in their classroom. The main mission really is to engage the students with scientist research and follow that scientific method. And really the key component is getting them comfortable to work with messy data, because in reality, a lot of environmental data is going to tell you a lot of interesting things. It's not all just black and white, it's very gray. And so there's 3 different types that the data nugget is put into on these online libraries. It ranges by different types. So we have a different type of difficulty based on the grade level. And then we also have our data nugget that is geared towards a junior and senior year high schooler. So it's a little bit higher up on the level of difficulty in the one that we're producing. So the data nugget can be broken down in 4 major parts is how I see it. We have the narrative of what the scientist is investigating and why. We then ask a scientific question that can be answered with the data that's provided. And then students need to identify those variables, of course. And then the main part of taking that data that they are provided and then answering all these follow-up questions. So the first part is called the narrative. And this is really where we're setting the stage. We're stating why the scientist is doing what they're doing, and then how that scientist was able to gather all of that data and the different methods that they were using. So as you can see here, here's our example of what we have so far. Our draft is still in its 3rd revision. So this is just an example of what it looks like right now. We then give them the scientific data after the narrative. So this is an example of the data set that we give the students to work with. And we ask a scientific question of, are halophiles useful as biological indicators of chloride pollution based on their quantity and presence throughout the year? So the student has to make graphs then based off this data. So we give them the sampling site. So we give them an urban and one of our rural sites on the Menominee River, the time of year that it was sampled with the average chloride concentration, and then they have to do a little bit of math to get the average of the bacterial colonies per gram of sediment. And that's what they ultimately end up having to graph. So then they identify the variables and we ask them to make 2 different graphs. So they have to kind of piece that together. Then of course, they have to construct the graph, or depending on the type of difficulty, you can also have a data nugget where that graph is provided, or on the other extreme end where they have to do the axes and also graph the whole entire thing. So the graph 1 shows the bacterial colonies across the month sampled throughout the year and the 2 different sites. And then on the graph 2 is the chloride concentrations. So they have to do this compare and contrasting to really interpret what's going on in the environment. And that leads it to in the interpretation part. And so example questions within the data nugget are, make a claim that answers the scientific question, or explain your reasoning and connect that data back to what you've learned about halophiles and road salt pollution. And then of course, science is an ongoing process. And so what kind of questions should be investigated further? And it kind of leaves like that creativity aspect to it, because science at the end of the day is a very creative discipline. And of course, we have our teacher resources that are built within the data nugget. So we're not just leaving the teachers hanging to figure out how to do all this stuff by themselves. And so it comes into 2 different versions. So we have a student copy and then the teacher copy. And the teacher copy has all of these helpful tips and tricks, like our teacher notes throughout the whole entire data nugget shown here. And then we also have explanations to all of the interpretation questions. So it's a very long document and it goes into extreme detail about the different things that that teacher could prep for that particular lesson, which is really cool. And then we have our supplemental materials at the end of all of this, which go along with the data nugget lesson. And so I had said that we made some docu-series videos that walk through my scientific process of my research. And so that docuseries will be included in the additional teacher resources section for them to be able to play in their classroom so that the students can kind of follow along and see that visual. And then also we have different experiments that the teacher could do in their lab or classroom and do other demonstrations and things like that. There's also just a bunch of different videos that they can use as resources while teaching this. And so, like I said before, we are in the 3rd revision of our data nugget right now. We just submitted it, but we are always looking for teachers to use this in their classroom. If any teachers are on this call that are interested in doing that. So, because we're always looking for feedback, we want to make this as good as possible and make it so that the students understand the material that they're walking through. So yeah, if you're interested in trying out our data nugget in your classroom, or you just have any questions about the research that we're doing here in the McClellan lab, I have my contact information listed, and I'll also be happy to take any questions at the end of our webinar today. Thank you.
Hi, everybody. I'm up next here, and I'm Kevin Anderson at the Department of Public Instruction. Like Allison mentioned, I help to coordinate science and STEM education through the state, and I'm always excited to talk about kind of interesting stuff that kids can and should be doing in their classrooms, in their communities. And so that example of the data nugget from Lexi, I think, is right on target with the types of things that we want, from state leadership standpoint, the types of things we want students to be engaged in. So I love that. And I like that connection to data nuggets too. That's a common tool that our science teachers use, especially at high school. So to see more of those being developed, and one developed with some Wisconsin specific data, I think is really cool. And I love being able to share that out with teachers. I look forward to that and being able to dig more into that too. And I'm gonna pull up some slides here as well. So that's taking a minute to get going for me. After today, like Lexi and Allison said, we'll have some time for questions, but also if there's anything I can do to help you out or resources to share down the road, there's my email here and I'll share it again at the end. And what I'm going to be talking about today is a vision of statewide inquiry. So, what is inquiry that students could engage in at school? What does inquiry-based learning mean, and why do we do it? I think are two key questions. And to frame that a little bit, I'll give an example of an amazing teacher named Dennis Rohr, who teaches up in the Seymour area. And in the news, his students had been hearing about how there is pollution in their own wells. So, it's a relatively rural community. And so there's issues with pollution in their wells. There's issues in pollution in individual wells all over the state, and lots of data you can dig into with that. And so in his class, they read some initial articles that kind of just sparked their interest and build up some background understanding. They came up with their own questions. They designed and conducted their own tests on the well water throughout their community, and then they shared the results with their community. And the key thing there, why do it? Why do these type of inquiry projects? Research shows it boosts student engagement, it supports scientific literacy, and from a DPI standpoint, it's certainly something emphasized within our state standards for science, and it's part of our vision of what we hope kids are doing. So to further encourage and support this idea of inquiry-based learning, over the past couple years and for the next couple years, we've been supporting an initiative that's a statewide inquiry project. And our theme for this statewide inquiry project is water. We first started and picked that theme in the year of freshwater that was proclaimed by Governor Tony Evers. And we've kept it going to keep kind of a consistent theme for years to really build up momentum and sharing among teachers. My partner in this that I should mention too is Travis Tangent, who works for the Wisconsin Alumni Research Foundation and supports outreach events with the community and connections between researchers and education, and supports events like the Wisconsin Science Festival, which is another place where I try to connect teachers with the cool research that's happening in labs like the McClellan lab where Lexi works, and all of the interesting things that can engage students in ways that, the typical textbook can't. And so our goals in this state inquiry project is really to get all students engaged in inquiry-based science projects across the state. That's something we hope is happening in every classroom K-12 each year. And we also want to, by having this kind of themed approach around water and some resources, there's the website on this slide, some resources so that teachers and other educators, informal educators across the state can start digging into some of these resources and sharing what they're doing with each other to build up some networking and say, hey, what are you doing related to our water in Seymour? Connect to some folks down in like the Platteville area that I know also have had some issues around well water, and start comparing data across the state. And those are the kind of connections that we hope with this state inquiry project around water. And as Allison mentioned in the intros, there is a common task that we've shared for this state inquiry project that we encourage educators to do, but honestly, educators could do any water-related inquiry work, and we'd love it and love to learn more about it. But our common task, where we hope to get some, an easier way to share data if it's a similar task across the state. This common task is a sweep. You might have in your communities talked about, doing a sweep project and seeing what comes up. And in this case, students go out to their school parking lots and they measure a consistent 10 by 10 frame on those lots and do a sweep of whatever's there multiple times through the year. And then in your intro early elementary classes, it could just be observations. What do we see at different times of year and what's there? Up through high school, where it gets a little bit more technical, they start to analyze those samples for things like salinity with refractometers or other pollutants that they might find there. And then the goal being that they share that data. And the way that we're encouraging folks to share that data is through this map-based sharing system called Sifter. And this will also help with networking to see what different folks are doing around the state. And I'm going to stop sharing this screen for a second and pull up the actual Sifter site. You can see a little bit of what that looks like. So as you go into Sifter, this is, there's the link on that slide, which is the SIFTR, sifter.org, and /Wisconsin Water. And so within here, we have a variety of projects from both educators and other community members who would welcome anybody sharing work that you're doing around the state. So some of the resources, you can see like the blue dots tend to be educators sharing lessons. Yellow dots, I think, are stories about water-related inquiry projects or learning. Red dots, you can have a filter for red as audio and video related to it. So we see that PBS Wisconsin has a few of those things. Blue dots, if I remember right, are data resources. So people have data related to water, and then yellow points are research projects related to water. So you can dig in and see these things happening all over the state, zoom into your area, and share as well. To share, you just have to create a simple user account, then hit the plus button, and it walks you through it pretty easily. And so again, we welcome the sharing of resources. Some educators question say, we don't really have time with everything we're supposed to teach for inquiry. And I would encourage, if you're an educator or someone that works with educators, I'd encourage you to emphasize that it's the most important thing that you'll have students do in a school year. They're doing this with a community partner. If they're doing this with their teachers in their schools, that's really what our state vision and goals are all about. And to pull a quote or idea from those state standards that we have, the goal is that students are making sense of the world around them and solving meaningful problems. I hope that that's what happens. And as Allison said, we definitely have time for comments and questions after this. But again, there's my resources website is dpi.wi.gov UW-Milwaukee/science/water. If you want to learn more about that state water inquiry project that we're doing right now, you can also reach me at that email address. So thanks for your time this afternoon, and I'll turn it back over to Allison.
All right, thank you, Kevin and Lexi. This is great. Lots of ideas hopefully are bubbling for folks. And as you were both sharing, I did put links to the Data Nugget website up, even though Lexi, I know yours isn't on there yet. I appreciate that you're willing to share the draft. I would say it's a very good draft out with teachers and get some more feedback. And then Kevin, I put in the links to the water inquiry lesson as well as the sifter. So hopefully we'll have a few questions come in here. There is a little bit of a lag between us sharing and then having it go to the YouTube. So I don't see any quite yet, but we'll just give it a second. And I'll maybe put in a plug for tomorrow's talk while we're on, which is a number of salt reduction success stories from across the state. So we actually have a representative from the DOT, a municipal staff from the city of Eau Claire, a private contractor from the Madison area, and then someone from Milwaukee Riverkeeper. They're going to talk about salt reductions in each of those, I say communities, but also like across the state. All those organizations have been doing a lot of great work. So hopefully people can join us for that.
I can throw out a question. So one question that I often get related to inquiry is, teachers will say, I want to do it, but I'm not quite sure how to fit it into my schedule. And one teacher that I'm working with a little bit right now is Jen Clark out of Glen Hills Middle School in the Glendale area. And in talking to her recently, she's doing some water work, kind of a sustainability theme, and they're looking at the city water, where water goes through a city, and thinking about how they can make things more sustainable in her class of students. And she noted that she takes, it's kind of an anchor project in her class. So it goes through most of the year, but they do the regular teaching and learning. And then they take a little bit of time each week to say, all right, let's connect back to this anchor project that we're doing and see how that's connecting to what we're learning in the regular class and builds toward that, but also just having something that's in the background all the time that students really are excited about, engaged about, and it's happening right there in their community, where at the end of it all, they're going to share their ideas and their models with their community members. So it's doesn't have to be something that takes the place of, but more supplements and supports what teachers regularly do in their classes.
Thank you, Kevin. Yeah, as someone with experience in the classroom, it's always hard when you feel like I've got all of this curriculum I have to get through. What do I have to push out, right? Even when those inquiry projects are the ones that tend to really engage students, and you can't recreate that. Okay, so we do have a couple questions that have come in. The first one is from Wilf. He has asked, on the data nuggets, do you do any discussion of statistical significance?
On our data nugget, we do not include any statistical analyses at all. The only mathematical part that they have to do is take that average of the biological triplicates and of the bacteria counts. I wanted to include maybe some statistical stuff, but we just kind of strayed away from it. So yeah, kind of just went off of what other data nuggets also have. So.
And thinking of where that lines up with state science standards, there is the hope that by the end of high school, that students are doing some statistical analysis of data in those high school science classes. And so wherever that can come in, it's great if it does for high school students.
Mm-hmm.
All right. And then we've got another question from Rick. Rick has said, Lexi, do you know if any of the data you're collecting is getting uploaded to the DNR's SWIMS program, where it can be viewed along with other monitoring data?
We have not had any talks about that, but that does raise a really good point, and that I think if anything, we're going to get a publication out with this data. So it'd have that supplemental material that you could request or download too. But I think it would be really useful to be able to put this on some kind of database where anybody who's interested in looking at it could have that time to do so. So that is a really good question. We'll have to look into that.
And we'd love to host it on the State Water Inquiry Project websites too. Your
Oh yeah, that'd be awesome.
article and your data nugget, and make sure that they're up there as well.
That'd be great. Thanks.
And the videos, right?
Mm-hmm.
Yeah.
Great. Yeah, I know that right now the DNR SWIMS program does not allow people to include any results that they have from the chloride test strip. So connectivity can go in there. And I think like state lab tests for chloride, but I mean, I feel like your data, Lexi, would be really incredible. And even to have you speak to the DNR's chloride working group at some point.
Yeah, I'm actually going to be speaking next month at, with their chloride work group. So that's already on the calendar. Yeah. But yeah, I think it would be really interesting to be able to sample other places in Wisconsin that aren't within the Milwaukee River Basin and see if those halophilic bacteria are there too. Because right now it just seems like, okay, yeah, we know that they're in the Milwaukee River Basin, but what do some of these rural sites in Wisconsin that are not in these metro areas, what are those bacterial populations look like? So I'd be interested to like sample elsewhere too, but we'll see. I can't be too ambitious. I have to graduate in May first.
Yeah. Yeah. We could see maybe about having a few other, graduate students across the state, or maybe even, who knows, some high school students.
Exactly. Yeah, it'd be cool.
Be inspired by your data nugget and recreate it. That would be really awesome.
Yeah, I love the idea of citizen science and getting high school, middle school, high school, or elementary kids involved in that as much as possible.
Oh, absolutely.
Yeah, do you have, okay, so we've got a question here from Wendy, and then I've got another question, but Wendy's asked, do you know if Minnesota has curricula to support this as well? We have a new charter school that may be interested in pursuing this. So I don't know if Kevin may be directed towards you.
So Minnesota's science standards are pretty much the same as Wisconsin's. They're both based on the national next generation science standards. And so if there's curriculum that works for Wisconsin, it's going to work for Minnesota too. So anything we've got up on our website and those ideas at our DPI, you could certainly use as a Minnesota teacher.
Great. Yeah, and in your lesson plan, I mean, at the end, you have the next generation science standards, right? That are.
I think we did that, yes. Made it a couple years ago, so I can't remember exactly how that section of the lesson looks, but I think so.
Yeah. Okay. All right, I got to go back here. All right, and then I guess I wanted to ask Lexi, do you know kind of like background levels for these halophiles in streams, kind of like pre-roads? Like, has anyone been looking at this? Do you have any historical data?
No, and that's what makes it so challenging, and why first our hypothesis was when we see the presence of them, maybe that could be an indicator, but what our molecular data tells us is that they're there year round. So now it's a matter of, okay, we know that they're a permanent community member. Let's try to measure those responses. And so what we're seeing is when we have like a jump in chloride at our urban sites, we see maybe like a delayed response in the halophiles and we see them jump up too. So it's a little different because what we thought we were working with was something that maybe wasn't there all the time, but now we're finding that they are. So we don't really have like a baseline at all that we're working off of because there isn't any literature about these salt loving bacteria in freshwater systems. So we're kind of like starting from the beginning and trying to understand it. Yeah, it's a little challenging.
So your data will be the baseline, basically.
Pretty much, yeah. It's all, a lot of preliminary stuff, yeah.
Challenging, but exciting.
Yeah, very much so.
Yeah. All right. So Wendy has said thank you with the kind of information about Minnesota. And I don't see any other questions right now. So looks like we're just about at 1 o'clock. So thank you both so much for your time today, the work that went into this, and your ongoing dedication to science, and especially your work around teaching folks about salt pollution. So thank you both, and I look forward to working with you some more. And Kelly has also said thank you, and she's excited to use the data nugget in her classroom.
Woohoo! Awesome. Thank you.
Thanks for having me. Take care.